Hello boys and girls, this is Mr. Kizik, and in this video here we're going to be looking at how to prove parallelograms in the coordinate plane. So there are three different methods. For your homework you're going to have to determine or figure out how to how to do each method here. And on a future grade assignment, but like for our future things and tests and whatnot, I don't care what method you use because any of them work, and it's not like if certain information is given you can use one or the other. You're always going to be given certain things, and you'll be able to use any of the methods. So the first method is proving that both pairs of opposite sides are congruent. So in other words, if we prove the distance from A to B is equal to the distance from D to C, and AD is equal to BC, then the figure's a parallelogram. Well, what do we use? Now think back to chapter 1. We use the distance formula. Remember, the distance formula is d equals the square root of subtracting the y's squared plus subtracting the x's squared. The second method is using to prove that both pairs of opposite sides are parallel. So if I prove that AB is parallel to DC and I prove that AD is parallel to BC, then I've proven the figure's a parallelogram. Well, think back to algebra. What formula, what thing tells you that two lines are the same or two lines are parallel? That's right, it's the slope formula. So remember, the slope formula is m equals subtracting the y's over subtracting the x's. Now, this last method, in this case here, you're proving just one pair of opposite sides are both congruent and parallel. So it doesn't matter which one you pick, you just pick one pair of opposite sides. So let's say I picked A, B, and DC. Well, if I prove that AB is equal to DC and those same two sides are parallel to each other, then it's a parallelogram. So in this case here, you're kind of combining both methods here. You're doing both distance and slope formulas. So let's look at an example of each type of method here just to see how it works. I will forewarn you, this is just a little bit tedious. So first one, number 1, says use the distance formula to determine if the figure is a parallelogram. So if I look at number 1 here, and with any of these problems, the first thing you want to do is draw your potential figure. And then it doesn't matter which corner you start with, like in this case here, A, and then you either want to go in a clockwise or counterclockwise position with the letter. So in this case here, let's say I start the A here, and I go counterclockwise. I have to do it like this. It is not like A, B, and then C, D. That's wrong. All right, so something like this, and there you go. Now really what you want to do is just pick a pair of opposite sides. So let's say you picked A, B, and DC first. So you're going to have to do the distance formula for AB. So AB is equal to the square root of, well, let's do the math. I believe in the equation we did y first. So AB would be 4 minus 2 squared plus negative 7 minus 1 squared. Well, 4 minus 2 is 2, right? And what's 2 squared? 4. 4 plus, what's negative 7 minus 1? Negative 8, and negative 8 squared is 64. So I get the square root of 68, and I don't need to go to the calculator to find a decimal. I could just leave it as that. Now I do the same thing for DC. DC is equal to the square root of, we could do negative 8, now it's minus negative 6, which really means plus 6 squared, plus 9 minus 1 squared. Well, negative 8 plus 6 is negative 2, squared is 4, because remember when I square anything it's positive. 9 minus 1 is 8, 8 squared is 64. And add them, and I get 68. So these are both the same. That does not mean, though, my answer is yes, it's a parallelogram, because if I look at the methods again, I need to prove that both pairs of opposite sides are congruent. Both pairs are parallel. So now I gotta do the same thing, but for AD and BC. So AD is going to be the square root of -7. Oh, well, we did y. Remember, it doesn't matter if I do x or y first. But I'll just follow the formula. 4 minus -6, or plus 6 squared, plus -7 minus 1 squared. 4 plus 6 is 10 squared. Ooh, a little delay there. Squared would be 100. -7 minus 1 squared is -8, and then 64. The square root of 164. Now I gotta do BC. BC is equal to the square root of 2 minus -8, or 2 plus 8 squared, plus 1 minus 9 squared. 2 plus 8 is 10, squared 100. 1 minus 9 is -8, squared is 64. Lo and behold, these are the same, so what does that mean? That means that this is a parallelogram. We have proven that both pairs of opposite sides are congruent to each other. That's method 1. Let's look at method 2, which is using the slope formula. Again, you want to reload the page. All right, so here, whoops, sorry. So here, the second method is using the slope formula. So again, with all these, you want to draw your figure, and then label your points. So let's say we picked WX and ZY. Yeah, WX and ZY. So let's find the slope of WX. So remember, it's subtracting the y, so -6 minus -4 plus 4 over 1 minus -7 or plus 7. So -6 plus 4, -2 over 8, and you always, just like you did before in algebra, reduce your fraction. Now let's find the slope of ZY. That's going to be -12 minus -13 or plus 13 over 1 minus 5. -12 plus 13 is 1. 1 minus 5, -4. Are these two the same? Yes, both these slopes are the same. So that means we have to now do WZ and XY. So the slope of WZ is going to be -12 plus 4 over 1 plus 7, which gives me -8 over 8, which is -1. Now do the slope of XY, and I would have -13 plus 6 over 5 minus 1. -13 plus 6 is -7. 5 minus 1 is 4. Are these the same? No, these are not the same. So therefore, this final answer is no, it's not a parallelogram. So let's say if you were doing this problem, you picked WZ and XY first to do. You would have only had to do it 2 times, just like here, find out they were different, and you would have been done. Sometimes just the look of the draw. That's why you have to check both pairs, because as you can see in this example, one side does work, but the other one doesn't. So it does happen. Last method here is using both the distance and the slope. So again, draw your figure. JKLM. Now, as it says here, use that method. You only pick, let's go back to what it said, you pick one pair of opposite sides. So it doesn't matter what you pick. Let's just go, continue with the pattern and pick J, K, and ML. I don't touch J, M, and KL at all. So with J, K, and ML, I use both the distance and the slope formula, and it doesn't matter which one you choose first. Let's do the distance because that's just more tedious and longer to do. So JK is going to be -2 minus 1 squared plus -9 plus 5 squared. Do the math here. I'm going to get -3 squared, 9, 16, 25. And yes, we know the square root of 25 is 5, but we can keep it like that. ML would be the square root of -7 plus 4 squared plus -3 minus 1 squared, which would give me, lo and behold, after I do all that, 9 plus 16, same thing. Now, what I'm going to do, using still JK and ML, now I'm going to do the slope formula. So the slope of JK is going to be 1 plus 2 over -5 plus 9, which gives me 3 over 4. Do the slope of ML. That's going to be -7 plus 4 over -3 minus 1, which gives me -3 over -4, which does reduce down to positive 3/4. Lo and behold, everything worked out. So therefore, yes, this figure is a parallelogram. All right. If you have any questions or concerns, please feel free to message me. Now, for your homework, what I would like you to do is, and it's not loading, I don't feel like refreshing it, but I believe numbers 10 through 12. Now, I know some of you have done that already. If you have done that also, if you have done that already, and even if you haven't done that already, I also do want you to try these practice problems 2, 4, and 6 here. If we were in class, I'd have you try them out anyway before you do the homework. So 6 problems there.